Given that k is a negative constant and that the function f of x is defined by f of x is equal to 2 minus x minus 5k times x minus k over x squared minus 3kx plus 2k squared, where x is greater than or equal to 0. Part A, show that f of x is equal to x plus k over x minus 2k. So I am going to need to take a common denominator to bring these two separate terms together to be one fraction in a minute. But first I want to see, is there any simplification I can do to this fraction? And there is, I think, because I think I can factorise this denominator. It's going to be a bit more awkward because we're dealing with k's rather than numbers, but let's see. We're going to have an x, we're going to have an x, we're going to have a 2k and a k to get the 2k squared. So I know I'm going to have a 2k and a k, and they're both going to have to be negative in order to have the minus 3kx. So let's just double check this. The x times the x gives the x squared. The minus 2k times the minus k gives plus 2k squared. And then the x times the minus k gives minus kx. And the minus 2k times the x gives minus 2kx. So the minus kx and the minus 2kx is minus 3kx. So yes, the denominator has now been factorised. And now I can see that the x minus k here and here will cancel out. So I can now say that f of x is equal to 2 minus, so we've still got the x minus 5k on the numerator, and we've still got the x minus 2k on the denominator. Now I'm going to get a common denominator. So this 2, if I write this as 2 over x minus 2k, I need to write an x minus 2k on the numerator as well. Now they have a common denominator of x minus 2k. On the numerator, I've got 2 lots of x minus 2k minus the x minus 5k. The numerator, so we've got 2x minus x, so that's just x. And then we've got the 2 times minus 2k, so that's minus 4k. So we've got minus 4k. And then we've got the minus 5k, so that's plus 5k. And then the minus 4k and the plus 5k is just going to be plus k. And this was what we needed to show for part A. Part B. Hence find f dash of x, giving your answer in its simplest form. F dash x, that's saying to differentiate. So I need to differentiate my function. So notice that this is a quotient. We have got the x plus k over the x minus 2k. So we're going to have to use the quotient rule to differentiate this. So let's clear a bit of space and we'll say that u equals x plus k and v equals x minus 2k. Differentiating the x plus k, I'll get 1. Differentiating the x minus 2k will be 1. Now remembering that the quotient rule is u dash v minus v dash u all over v squared. So we would have 1 times x minus 2k minus 1 times x plus k all over the v squared. Simplifying the numerator, we've got the 1 times x, so we'll have x, we've got the 1 times the minus 2k, we've then got the minus x and the minus k. The x terms cancel out, and so we just get minus 3k over x minus 2k all squared. So that's my answer for part B. Then for part C, state with a reason whether f of x is an increasing function or a decreasing function, and we need to justify our answer. Remember that an increasing function is one that has a positive gradient. A decreasing function is one that has a negative gradient. So the question's asking, is this positive or is this negative? Well, first thing, the denominator is definitely positive because it's squared. That squared there means that this denominator is always going to be positive. So what about the numerator? Well, I've got minus 3k. Now remember that k is negative. We were told this in the question. So if k is negative, minus 3k, so minus 3 times that negative k, minus 3 times a negative is going to be a positive. Therefore, the numerator is also positive. And if the numerator is positive and the denominator is positive, therefore the whole thing is going to be positive, and if the gradient is positive, it's an increasing function. So I need to state and explain this. So I'm going to say f of x is an increasing function because k is negative, so minus 3k is positive. X minus 2k squared is positive because it's squared. Therefore, f dash of x equals a positive divided by a positive, which is positive, so greater than 0, therefore increasing. And we're done.